All right, let's get started. We're going to add some incredibly powerful yet super simple tools to your mental toolkit. These are tools that help us organize and understand the world in a really logical way. Now, this might sound like a bit of a riddle, right? But the answer is actually surprisingly simple, and it reveals a really powerful way of thinking. Go on, take a second to think about it. You got it. You can sort them into groups, or what we call sets. And in this explainer, we're going to build that toolkit. We're going to understand the simple but really powerful rules that decide how these groups interact with each other. Okay, so tool number one in our toolkit is all about finding that common ground. It's called the intersection, and it's how we see what different groups share. So the absolute key here, the word you've got to remember is and. The intersection is the collection of things that are in set A and in set B at the exact same time. Not one or the other, it has to be in both. Okay, let's make this real. Let's say set A has the numbers 1 through 5, and set B has some even numbers, 2, 4, 6, 8, and 10. So what's in both? Let's just look for the overlap. Well, the number 2 is in both sets, and hey, the number 4 is in both sets too. And that's it. So the intersection of A and B is simply the set containing just 2 and 4. All right, tool number 2. What if we don't want to find just the overlap? What if we want to throw everything together into one big pile? Well, for that, we've got the union. And if and was the key for intersection, then the magic word for union is or. An element gets to be in the union if it's in set A, or if it's in set B, or even if it's in both. We're just creating one big combined group. Now, check out how this handles duplicates. Look at set A and set B here. You can see the numbers 1 and 7 show up in both sets, but look at our final union. We only list them once. That's because a set is just a collection of unique things. So the union basically scoops everything up and then just gets rid of any repeats. So let's put these two head to head. It really boils down to this. Intersection is all about and. It's for finding what's in common, which usually gives you a smaller set. Union is all about or. It combines everything, which usually gives you a bigger set. It's kind of like intersection is zooming in with a magnifying glass, and union is taking a big wide-angle photo. Okay, our third tool tackles a totally different kind of question. So far, we've been asking what's in the group. But what about everything that's not in the group? For that, we need this idea called a complement. But wait, before we can talk about what's not in a set, we first have to agree on what could possibly be in it. We have to define our boundaries. And that's where the universal set comes in. Think of it as the entire world for this specific problem. If we're talking about numbers, maybe our universe is all integers. If we're talking about a deck of cards, the universe is all 52 of those cards. It's the sandbox we're playing in. Okay, so once we've defined our sandbox, our universe, the complement is super easy. The complement of A is simply every single thing inside that universe that is not in A. The keyword here, you guessed it, not. Let's use a really simple example. Imagine our entire world, our universal set, is just all the integers. And let's say set A is all the odd numbers. So what's left? What's in our universe that is not odd? Well, it's got to be the even numbers, right? So the complement of the set of odd numbers is the set of all even numbers. Simple as that. Okay, the moment of truth. We've built our toolkit. We've got intersection for and, union for or, and complement for not. Now let's put them all together and see how they help us solve something a little more complex. All right, let's break this down piece by piece. The problem asks for the intersection of the complements of A and B. Whoa, don't worry, we just follow the steps. First, what's the complement of A? That's everything in our universe that isn't 6 or 7. So that's 1, 2, 3, 4, 5. Got it? Next, the complement of B, everything that isn't 3, 5, or 7. Okay, that gives us 1, 2, 4, 6. Now we've got our two new sets. The last step is to just use our first tool, find the intersection. What's the overlap between those two new sets we just made? Let's see. 1 is in both, 2 is in both, and 4 is in both. And that's it. So our final answer is the set 1, 2, 4. We did it. So that's the mechanics of it. But you might be thinking, okay, that's a neat logic puzzle, but why does this actually matter? Well, it turns out these super simple rules are pretty much the bedrock of our entire modern world. Seriously, every single time you use a computer, you're using this logic of and, or, and not at its most basic level. When you search online for restaurants near me and open now, you are performing an intersection. Data analysts use this to find out which customers bought a product but not the warranty.
It's absolutely everywhere, just quietly sorting the world around us.
And that really brings us to the final thought I want to leave you with. Now that you have the toolkit, now that you know the language, you're going to start seeing these operations everywhere when you're picking a movie, filtering emails, or just deciding what to eat. So the real question isn't if you use set theory, it's how many times you've already used it today without even thinking about it.